What's up, guys? It's Mr. Brengle, and today we're going to be doing the keeping track of momentum hit and bounce collision concept builder. So we already did one that was hit and stick, but now they're going to be bouncing. So the two carts will not stick together, they will go off individually. Okay, so kind of down here, I've kind of written out the formula of what we're going to be doing here. There's going to be, it's very similar to the last concept builder, but we've got the red cart and the blue cart, and they're separate on the initial side. So this part right here, you're going to have situations. The red cart will always be moving. The blue cart could be stationary, not moving, or it could also initially be moving. So this is your initial side. Terrible writing there. Okay, and then your final side over here. Since the carts are not connecting, they're moving separately, so we will have to consider the individual momentums of each. If you remember on the previous one, we would do it like this. We would do, red initial plus blue initial is equal to the red plus the blue together, right? Because they combined on the final side. Okay, but we're no longer doing that. Okay. All right, so let's go ahead and move on here, and I'm going to go through a couple problems with you on each level here. So we'll start on the apprentice level, and just like the hit and stick one, this time it's actually just giving you the momentums up here. Okay, so it says the red cart is moving rightward. This is important because this time we're going to have, at least on your third trophy, you could have an object that's moving to the left. We do need to be careful about that. Right would be positive, left would be negative. Okay, so anyway, the red cart's moving rightward with a momentum of 80 kilograms times centimeter per second when it collides with the blue cart that is initially at rest. Okay, so the blue cart is at rest. So we can go ahead and fill in the initial side of the equation here. The red cart is moving with 80 units of momentum. The blue cart is stationary, and therefore the system momentum 80 plus 0 is just 80. Now, we know that the momentum of the system before the collision must be equal to the momentum of the collision after. So this bottom one also has to be 80. And we know that the momentum change of the system in total is 0, okay? Now, let's look at the rest of this to figure out what we need to do for the final side. So it says the collision causes the red cart to slow down and the blue cart to set in motion with 20 units of momentum. Okay, so blue now has 20 units of momentum. So what we're going to do here is we're going to go plug in 20 for the blue, and then based on this, you can figure out the chart. I'll show you the math. I'll show you how to do this with math. But right now, I know that the blue cart has gained 20 units of momentum, so I can put that here. For the system momentum change to be 0, that means that the red cart had to lose 20 units of momentum, right? So that means that this would go down to 60, and 60 plus 20 is 80. So now all this adds up, right? The momentum before the collision was 80. After the collision, it's 80. There's no momentum change. There's positive for the system. There's a positive change in momentum for the blue cart of 20 units of momentum, and then the red cart is going to lose 20 units of momentum. Okay, so now let's look at this from the equation standpoint. So remember that we are going to be doing it like this. It's going to be the red initial plus the blue initial is equal to red final plus blue final. Okay. So now if I actually, plug these numbers in here, I would plug in 80 plus 0. So the 80 is the momentum of the red cart before the collision. The 0 is the momentum of the blue cart before the collision. And then that's going to be equal to the red cart's momentum, 60 after the collision, plus the blue cart's momentum after the collision, which is 20. Okay, so right here at this point, when you've got this, you can fill out the chart. So you could start by doing the equation, like I just did, or you could just go through the chart kind of like I did initially there, okay? So either way works, but now, like, I could have just, if I hadn't filled out the chart, I could take this 80, plug it in here, take the 0, plug it in here, fill this out, okay? And then I figured out the final side as well. It's just a different way of doing it, okay? Let's go ahead and check our answer. We are correct. Let me get rid of all this stuff. I'm going to leave that formula down at the bottom there, though. And let's continue. Okay, we'll just do a couple examples here. So, all right, we'll do this one a little bit faster. And I'll do this the opposite way first. So this time it says that the red cart is moving rightward with a momentum of 100 kilograms times centimeters per second when it collides with the blue cart that is also moving rightward. Okay, blue cart also moving rightward at 80. Okay, so there's our initial slide. Let's go ahead and fill that out real quick. So it told us that the red cart is moving with an initial momentum of 100 kilograms times centimeters per second to the right. Now, because the blue cart is also moving to the right, we're going to add these momentums together. So the blue cart's initial momentum is 80, and we're going to leave it like that, okay? So now I could plug in the initial for the red cart is 100, the initial for the blue cart is 80. Now, I want you to understand, if the blue cart was initially moving to the left, then that would have to be a negative 80 because it's in the opposite direction of the red cart, okay? Total momentum here is 100 plus 80, so 180. That means our total momentum after the collision must also be 180, and we know that that means that there would be no momentum change for the whole system, okay? All right, now, for the final side here, it says that the red cart slows down, and it doesn't tell us specifically to what, so we're going to have to figure that out. And it says that the blue cart increases its momentum to 140 kilograms per second. So that means that whatever we do here, this is going to be x plus 140. Okay, so you can see that on the right side, or on the initial side here, we have a total of 180 units of momentum, and that is equal to x plus 140. And then we obviously know that x must equal 40 for this to add up to 180, okay? So that means that after the collision, the red cart has, its momentum has decreased from 100 to 40, okay? And the blue cart's momentum has increased from 80 to 140. So both of them experienced the momentum change of 60 units of momentum. It's just that the red cart lost 60 and the blue cart gained 60. Okay, go ahead and submit our answer. Okay, great. So that one, you know, this first trophy here is nice because it gives you the initial momentum, so you don't have to do any calculations. You've had these types of charts before. The momentum change here that it's highlighting the momentum change of the red and the blue and how they're equal and opposite. So you would want to find something like that. The momentum lost by the red cart is equal to the momentum gained by the blue cart. Okay. All right, let's go ahead and move on to the next trophy. At this point, it's going to make you do math. It's going to give you, instead of just giving you the initial momentum as a solid number, on the Master Trophy, it's going to give you masses and velocities. So we're going to need to consider those, okay? And we'll do it the same way, though, okay? So it says a 1 kilogram red cart is moving rightward with a speed of 60 centimeters per second when it collides with a 0.5 kilogram blue cart that is initially at rest. Okay, so let's set up the initial side of the collision here. Okay, so it has told us here that, remember that momentum is mass times velocity. So for the red cart, its mass is 1 kilogram times 60 centimeters per second. Okay, that's the initial momentum of the red cart. Plus the initial momentum of the blue cart, which is initially at rest. We know that that is just 0. Okay. Now, on the final side here, we know that the red cart still has a mass of 1 kilogram. We're going to multiply that by some velocity that we'll have to, we'll figure that out here in a second. And then the blue cart is still going to be 0.5 kilograms times some velocity that we will figure out right now. Okay? So let's read the next part of the question. It says, after the collision, the blue cart begins moving rightward. So blue cart moves rightward with a speed of 80 centimeters per second. Okay? So I'm going to go ahead and fill that in down here. 80 centimeters per second for the blue cart. It then says that the red cart is still moving rightward, but has slowed down to a speed of 20 centimeters per second. So red cart, 20 centimeters per second. So I'm going to plug that in here. Okay. So we can now see that the initial momentum of the system is a total of 60 units of momentum, right? And it's all from the red cart. So we have 60 on this side is equal to the red cart's final momentum is 20 units of momentum plus the final momentum of the blue cart, which is 80 times 0.5, which would be 40. So you can now see that they do add up there. So at this point, we can fill out the table. We know that the initial momentum of the red cart right here is 60 units of momentum. We know that the blue cart is initially stationary, so we'll plug in 0. 60 plus 0 is 60 for the system momentum. We know that the system momentum after the collision must match before the collision, so it's also 60. And therefore, the total momentum change of the system is 0. Okay? After the collision, the red cart is now moving with 20 units of momentum. And the blue cart is moving with 40 units of momentum. So the blue cart gained 40 units of momentum and the red cart lost 40 units of momentum. We'll go ahead and check our answer here. Awesome. Okay. So you can see that one's a little bit different because we had to do the, we actually had to calculate the initial momentum and the final momentum instead of it just being given to us. Okay. So let's do another one. Okay, so same thing here. The red cart, so 1 kilogram red cart is moving rightward with a speed of 40 centimeters per second. It then collides with a 2 kilogram blue cart that is initially at rest. So once again, we can go ahead and fill out the initial side of this equation. And we can say, okay, well, there's a 1 kilogram red cart. It's moving at 40 centimeters per second. Okay, to the right, and plus the initial momentum of the blue cart, which is going to be 0 because it is not moving. Okay, now after the collision, the blue cart begins moving rightward with a speed of 15 centimeters per second. Okay, and then it says that the red cart is still moving rightward, but has slowed down to 10 centimeters per second. Okay. So the red cart is still 1 kilogram, and it is now moving at 10 centimeters per second, plus the blue cart, which is now, it's no longer stationary, it's 2 kilograms, and it is now moving at 15 centimeters per second. Okay? So we know that the 1 times 40 here is going to give us an initial momentum of 40 units. And just understand, the reason I'm saying units of momentum is because typically we use kilograms times meter per second. This program is using kilograms times centimeters per second. And that's a bit of a mouthful, so just in the interest of time, I'm just calling them units of momentum. On the final side, the red car, whose initial momentum was right here, it's all red for 40, it has lost momentum and is now 10 units of momentum plus the momentum of the blue cart over here, which is 30. Okay, so now we can go ahead and fill out the chart. So the initial momentum of the red cart was 40 units of momentum. The blue cart was not moving, so it's 0. Therefore, the total system momentum is 40 before the collision. Therefore, it must be 40 after the collision, and there can be no change in the system's momentum. Now, we know that the red cart finished with 10 units of momentum and the blue cart finished with 30. Therefore, the momentum change for the red is negative 30, and the momentum change for the blue is positive 30. Okay. Good deal here. So there's a couple examples for the Master Trophy. And now we can go ahead and move on. I'll go ahead and cover this one again. So it's just highlighting that the system momentum is the same before and after the collision. So we want to find the one that says that. So the third one here, the system momentum before the collision equals the system momentum after the collision. Great. Okay, now let's go ahead and move on here to the wizard level. Now, this is the only trophy that I have experienced objects moving right and left. Okay, so just be careful with that, because for the majority of all of these, the objects are just moving to the right. You need to be really careful and make sure that you are underlining things like I am, just to make sure that it doesn't tell you that one of the carts is moving to the left. Okay, so on this one, 1.5 kilogram red cart is moving to the right with a speed of 60 centimeters per second. It collides with a 0.5 kilogram blue cart that is also moving rightward with a speed of 40 centimeters per second. Okay. So let's go ahead and set up the equation here. Obviously on this one, both carts are moving initially instead of just one. So we got 1.5 kilograms for the red cart. It's moving with 60 centimeters per second of velocity, plus the blue cart, which is 0.5 kilograms times 40 centimeters per second. Okay, so there's our initial side of the equation. So then we can obviously see here that the blue cart initially has 20 units of momentum. The red cart initially has 90 units of momentum, 1.5 times 60. And then that's going to be equal to the final side, which we need to figure that part out. Okay. So it says after the collision, the red cart moves rightward but slows down to 50 centimeters per second, while the blue cart speeds up to 70 centimeters per second. Okay. So over here on our final side, we've still got a 1.5 kilogram red cart, and we're multiplying that now by 50 centimeters per second, plus the blue cart's final momentum, which is 0.5 kilograms times 70 centimeters per second. Okay. So for the red cart, its final momentum is now going to be 75 units of momentum, plus the final momentum for the blue cart, which is going to be 35 units of momentum. So you can now see that 90 and 20 is 110, and 75 and 35 is also 110. Okay, so let's go ahead and fill out the chart. So basically the initial side, we've got 90 units of momentum for the red cart right here. Okay, the blue cart right here has 20 units of initial momentum. Therefore, the system momentum is 110. The final must also be 110, and there must be 0 system momentum change. After the collision, the red cart is now moving at 75 units of momentum. The blue cart, now 35 units of momentum. So you can see that the red cart lost 15 units of momentum and the blue cart gained 15 units of momentum. Go ahead and check our answer. Uh-oh, I did something wrong. Let's get this to go away. Oh, I just put a negative sign here instead of a positive sign. Whoops-a-doozies. There we go. Okay. So, So obviously that one now is different from the Master Trophy, where you have to now account for the blue cart, which is also moving. Okay. So I am going to keep doing this until I'm going to do another example with you. I want to find one where it gives you one of the carts moving to the left. So I'm going to move through this one just a little bit quicker. Okay, I'm not going to include units when I write, just for the sake of time, since we've done this enough now. Okay, 1 kilogram red cart, rightward, moving with 40 centimeters per second of velocity. The blue cart is 0.5 kilograms, also moving to the right at 20 meters per second. Okay, so on the initial side, we've got 1 kilogram times 40 centimeters per second, plus the blue cart, which is 0.5 kilograms times 20 centimeters per second. Okay. Now it says that after the collision, the red cart moves rightward, continues to move rightward at 30 centimeters per second, and the blue car is at 40 centimeters per second. Okay, so now I can plug in here that 1 kilogram red cart is now moving at 30 centimeters per second, and then the 0.5 kilogram blue cart is now moving at 40 centimeters per second. Okay, so I now know that my initial momentum for the red cart is 40, and my final momentum for the red cart is 30. Then looking at the blue cart, my initial momentum is 10 units of momentum and final is 20. And you can see that the initial side is equal to 50 and the final side is equal to 50. So we can go ahead and plug this in here. 40 for the red cart, 10 for the blue cart. System would be 50 before the collision and after the collision. No momentum change. Red cart decreases to 30 and blue cart increases to 20. Great. Okay. Let's go ahead and see if we can find one where a cart is moving to the left. Okay, perfect. Okay, so let's take a look now at this one. So we've got a 0.5 kilogram red cart that's moving rightward at 60 centimeters per second. It then collides with the blue cart, which is 1 kilogram, moving leftward with 30 centimeters per second of initial velocity. Okay, now, you just got to be super careful on this, okay? So we have a 0.5 kilogram red cart moving 60 centimeters per second, okay, initially. Now, the blue cart, since it's moving to the left, we have to make its initial velocity negative. So this has to be a negative 30 centimeters per second. Okay. So, we can go through now and say, okay, well, our initial momentum for the red cart is 30 units of momentum. And then I'm going to leave this as a plus sign here, but it's negative 30. The reason I like to do this, I just like to put the negative 30 in parentheses so that it's like really obvious and we can't miss it. So it's 30 minus 30, okay? But I'm doing 30 plus a negative 30 and leaving that in parentheses just so that it's obvious and we see it. Okay. Now, moving on to the final side. After the collision, the red cart moves leftward at 40 centimeters per second, and the blue cart moves rightward at 20 meters per second, or centimeters per second. Okay, so basically what's happened here is that the red cart is moving this way, and you've got the blue cart that's moving this way. So when they hit each other, the red cart is transferring all of its momentum to the blue cart, and the blue cart, so they're going to meet right here, is going to the blue cart will transfer its momentum to the red cart, right? So they hit, they hit in the middle right there, and then they start going opposite directions. Okay, so basically this one has an initial negative momentum, but then the red one has a final negative momentum. Okay, so this side is positive and this side is positive because of the direction that they're moving. Okay, so let's finish this out now. So the red cart here is now, so it's 0.5 kilograms times, it's now moving at negative 40. And then for the blue cart, it is going to be 1 kilogram times positive 20. Okay. So we can now see that this is negative 20 for the red cart plus a positive 20 for the blue cart for momentum. Okay. So the red cart's initial momentum is positive 30 because it's moving to the right. And in fact, what I'm going to do here is we're going to put arrows on here. Now, the blue cart is initially moving to the left. Okay? So that is going to be a negative 30. Whoops. All right, now the total system momentum here is 0 because they're moving in opposite directions. That means that they have to be moving in opposite directions after the collision and also add up to 0. And the momentum change would be 0. Okay, now after the collision, the red cart is now moving to the left and the blue cart is moving to the right. So we have to show that the red cart's momentum is now negative 20 and the blue cart's momentum is positive 20. Notice that these two add up to 0. And the momentum change, be careful here. The final momentum is negative 20. The initial is 30, so that's a momentum change of negative 50. And over here, this would be a positive 50 momentum change because we went from negative 30 all the way up to 0 and then to 20. Okay? So we'll check our answer here. And you can see that we have gotten it. So let me know if you have any questions on that. That's that wizard level there, especially when they throw the leftward moving carts in, can be obviously a little confusing. But I have faith in you guys. Did a great job on the last one. Okay, so let me know if you have any questions.